Assalamualaikum and hi. First of all, let me thank you to our valuable lecturer, Miss Siti Sarah. My name is Nushira Batrisha binti Rahiza. Let's get to know my team members. Nur Aina Nabihah binti Abdul Jamil. Next is Nur Hanis Fazira binti Hermi Faisal. Lastly is Nur Filzah Zahida binti Ahmad Muzaffar. We are going to talk about railway ticketing service. First of all, let's start with introduction. KTM Railway Company wants you, an intern, to design an efficient algorithm to handle the problem of seat availability and booking conflicts in a train ticketing system, taking into consideration a few factors. This company offers ticket price for selected origin and destination, numbers of passengers based on their age, concession type, and price. In addition, display the appropriate message when the user enters any invalid concession type. Calculate the total price. Discount will be applied for OKU to 15%. The payment type for card and online will get 10% discount. You can see here the schedule provide contains origin start with Padang Besar and there is 3 destinations which is Arau, Alostar and Sungai Petani. Next, the concession type have gold and platinum. Last but not least, we display price based on their age.
This is our objective. The first one is convenient. The goal is to make ticket purchasing procedure as simple as possible for customers, allowing individuals to purchase their ticket quickly and conveniently without the need for a physical ticket officer or interact with other staff. Second, efficiency. To minimize the waiting time. This is why we introduced the ticket machine. It are meant to provide a user-friendly interface that effectively guide customers to the ticket selection and the payment method. The third is accessibility. To make ticket purchase available to the customer 24 hours a day, 7 days a week, whenever they want, including during off-peak hours.
Furthermore, for the problem analysis, we define that this problem creates to help humans buying railway tickets more convenience, efficiency, and accessibility. For input, we declare the origin, destination, concession type, age, and packs. Second, the process we include the process of adding the discount for disabled person. We also apply discount if the users paid using card or online banking. Then we calculate the subtotal and total. Lastly, for the output, we include the origin, destination, concession type, age, packs, display subtotal, and lastly, display total.
So the next one is the solution to the problem. There are 2 solutions. The first one is pseudocode. As usual, to begin the pseudocode, we have a start and then we declare age, origin, destination, train type, price, packs, user, continue, discount OKU, discount payment is disabled, subtotal, total, price 1 until price 6. Then we set discount OKU to 15% and 10% for discount payment. After that, we prompt the user, do you wish to start? Y for yes and N for no. And then we read user continue. And then we start a while loop. User continue does not equal to the letter N. This means that if the loop will continue as long as the user does not put the letter N. And then do, meaning that the beginning of the loop's body. And then we prompt the user to enter origin, destination, train type, age, and packs. If origin equals to Padang Besar and destination equals to Arau, and if train type equals to gold, if age is more than 0 and age is less than 15, price is equal to RM1.50. Else if age is more and equal to 15 and age is less than 60, price is equal to RM3. Else, meaning that the user enter age that is not fulfilling the previous condition, meaning that they are above the 60 years old, 60 and above, the price will be RM2. And then the next if age is greater and equal to 0, we prompt the user if they are a disabled person, Y/N, meaning yes or no. And then we read is disabled. If is disabled equals to Y, assign price to the new value, which is price minus price multiply discount OK. Else, if the user entered other than Y, price is just equal to price. And then we calculate price 1, which is equals to price multiplied by packs. And then we move to the next else if. Train type equals to platinum. If age is more than 0 and age is less than 15, price is equal to RM4. These are more expensive since it's a platinum type. And then else if age more than or equal to 15 and age is less than 60, price is equals to RM8, else price is RM6. If age is greater and equals to 0, we prompt the user if they are a disabled person, just like the previous one. And then we count the new price. We assign price 2 to the new value. No. What I mean is we calculate price 2 instead, which is equals to price multiplied by packs. And else if origin equals to Padang Besar and destination equals to Alor Star, if train type is equals to gold, if age is more than 0 and age is less than 15, price is RM3. As if age is more and equal to 15 and age is less than 60, price is equal to RM5. Else price is equal to RM4. And then we ask the user if they are the disabled person, just like the previous one. And then we calculate price 3 equals to price multiplied by packs for that condition. Else if train type equals to platinum, if age is greater than 0 and age is less than 15, the price is RM7. As if age is greater than and equal to 15 and age is less than 60, price equals to RM12, else price is equals to RM8. And then we ask the same question if they are a disabled person, we apply the new price. And then we calculate price 4, which is equals to price multiplied by packs for that condition. And else, we display invalid train type if they put anything other than gold and platinum. And then else if origin equals to Padang Besar and destination is Sungai Petani. If train type equals to gold, if age is greater than 0 and age is less than 15, price is RM4.50. Else if age is greater and equal to 15 and age is less than 60, price is RM7, else price is RM5. And And then we ask the same question if they are a disabled person. If yes, if the user enters the letter Y, we assign a new value. We give discount to the person. And then we calculate price 5, which is equals to price multiplied by packs. Else if train type is equals to platinum, if age is greater than 0 and age is less than 15, price is 10 ringgit. Else if age is greater and equal to 15 and age is less than 60, price is 15. Else if they are above 60, the price is 11 ringgit. And then we prompt the same question if they are a disabled person, and then we give the discount price. And then at the end we calculate price 6, which is equal to price multiplied by packs for that condition. Else, invalid train type, if they entered anything other than gold and platinum. And then else, display invalid origin and destination if they entered another origin and destination from the previous conditions. And if. And then we prompt, do you wish to continue? Type N to stop. And then we store the user's input to user continue. And then we end the loop. And after that we calculate subtotal, which is equals to price 1 plus price 2 plus price 3 plus price 4 plus price 5 plus price 6. And then we display subtotal, which is equals to subtotal. And then we prompt, please enter payment type, cash / card / online. And then we read payment type. If payment type equals to card or payment type equals to online, we set total equals to subtotal minus subtotal multiply discount payment. It's a new total. And then else, total just equals to subtotal. If they choose cash, if they type cash, if they input cash to the prompt, the total equals to subtotal. And then we end if. And then at the end we display total. That's the end for pseudocode. And then the next one, we have our flowchart. As you can see, this is our flowchart.
Discussion. The code declare and initialize several variables such as age, origin, destination, trim underscore type, price, packs, user underscore continue, discount OKU, discount payment, is disabled, subtotal, total, price 1, price 2, price 3, price 4, price 5, and price 6. The variable discount, OKU, and discount payment are set to 0.15 and 0.1 respectively, representing the discount percentage for disabled individual and payment type. Second, the code prompt the user with the message, do you wish to start? Type N for no, and reads the user response into the variable user underscore continue. The code enters a while loop that continues as long as the user's response is not N. This loop allows the user to calculate multiple ticket prices in a single session. Third, inside the loop, the code prompts the user to enter the origin, destination, train type, age, and number of passengers. The corresponding values are read into their respective variable. The code then checks the origin and destination values to determine the ticket price on different conditions. For each valid combination of origin and destination, there are specific conditions for different train type and age range. 4. If the origin is Padang Besar and the destination is Arau, the code sets the train type. If it is gold, the code sets the price based on the age range. If the age is greater than 0 and less than 15, the price is set to Rm 1 ringgit and 50 cents. If the age is between 15 and 60, the price is set to Rm 3 ringgit. Otherwise, the price is set to Rm 2 ringgit. 5th, after determining the base price, the code checks if the age is greater than or equal to 0. The prompt the user with the message, "Are you disabled person? Y or N?" If the response is Y, the price is discounted by multiplied by 0.15.
The code calculates the price one by multiply the base price by number of passenger packs. Similar calculations are performed for other combination of origin and destination, train types and age range, resulting in price 2, price 3, price 4, price 5 and price 6. If an invalid train type is entered, the code displays the message "invalid train type". If the combination of origin and destination is not valid, the code displays the message "invalid origin and destination". After calculating the individual price, the code prompts the user with a message, "Do you wish to continue?" Type N to stop, and read the user response into the variable user_continue. When the user decides to stop, the code calculates the subtotal by editing all the individual price. Price 1, price 2, price 3, price 4, price 5, and price 6. The code prompt the user to enter the payment type, cash, card, or online, and read the response into the variable payment type. If the payment type is either card or online, the total price is discounted by multiplying discount payment. Finally, the code displays the subtotal and the total price to the user. The program ends.
In conclusion, this solution is achievable to complete and satisfy the problem by choosing the correct control structure. We make this KTM ticketing service as the example of the problem shows that the algorithm can elaborate and represent the advantages of using the correct pseudocode and flowchart. We can use this problem solving if any conditions that may occur or will be added after. Apart from that, algorithms can be revised and improved over time. By analyzing the performance and outcomes of the algorithm, we can identify areas for enhancement and iterate the solution. This interactive process of improvement helps refine problem-solving tactics and leads to more effective and optimal solutions. Other than that, we also use flowchart as documenting problem-solving approaches. They serve as a reference and can assist in creating standard operating procedures for problem solving. It offers a systematic and visual approach throughout the problem. Lastly, algorithms help in problem solving by making a step-by-step guidance that ensures users don't miss any essential elements and helps you maintain a logical flow throughout the problem solving process.